Okay, no problem. Good morning, guys. So today our agenda is to talk about the basics of the client server architecture, and we will also touch base on the different roles of data analyst, data engineer, and BI developer. And then, if time permits, I'm going to introduce you to the big data as well. So let me get started with the client server architecture. So, in general, a client is nothing but somebody who is requesting information through the internet. Okay. So the server, on the other hand, is nothing but someone who is providing that information. All right. So what happens in the organizations is that they generally follow this client server architecture where they host the servers in their locations, and then they allow clients to talk to those servers to gather information about the users or to request some information about the organization. So that's how things work, and they use internet as the medium of communication in general, right? So if we relate this to data engineering or in general, um, I think we could all I mean we could talk about the restaurant, which is a general example where we can consider a kitchen as a server, and then the person who is waiting for the item or the dish is can be considered as a client. Okay. And the person who is acting as a waiter or a server over there is nothing but the internet, right? So what happens in general in industry is that let's assume that there is a small MNC, and they have multiple uh, databases. So what they do is they are going to host all of their databases in a single location, okay, in multiple servers. So that single location with multiple servers is known as a data center, right? So what happens is, I'm assuming you are aware of what a server is, what a client is. Server is nothing but a supercharged computer, I would call, which means that it contains everything that a normal computer has, like RAM, ROM, and then the network IC cards, all the other CPU, everything else that a normal computer has. But the server contains a bit more capacity, okay, to handle multiple requests from multiple clients. That's server, and client can be anyone. It could be a browser, or it could be a mobile, or it could be a tablet, it could be anything that is requesting information from this server, right? So what happens is, in general, in MNC, in a small companies, what happens is they are going to create multiple servers. They are going to create multiple servers in a single location. Okay, so maybe that location could be close to their office. That location could be nearby their office. Now, this single location hosting this multiple servers is nothing but a data center. So what they do is, when they host these multiple servers, they need so much of resources, right? Servers are going to create so much of heat. They need so much of cooling methodologies. They need security. They need electricity, right? They need so many resources. So what they are going to do is they are going to keep this far from their uh, office location, and what they are going to do is they are going to use the optical fiber cables to connect to these servers, or sometimes they use the access based systems to connect to these servers through internet. Okay, so there are certain challenges with this approach, because what happens is that within these servers, when they host multiple databases, the challenge is that if you look at this approach, they are hosting everything in a single location, guys, which means that if by any chance, if this location is if something disastrous happened in this single location, let's say there is power cut or there is some unavailability of cooling techniques or water providing is not possible, then the whole data center is gonna go down, right? So that is something that we call it as server down. If we go to any bank or if we go to any government offices, we sometimes hear that there is server down, right? So what that means is that the servers located for this service went down due to some issue, right? So when we host everything in a single location, in a single data center, there is a high chance that we may lose the availability of data because of server going down. That's a one challenge, which we also call it as a single point of failure. Okay, which means that we are looking at only one location for everything, and that can cause a problem of single point of failure. Okay, now the second challenge of hosting data in a single location is cost. Okay, so assume that today we have a requirement of 100 GB of RAM. Okay, and let's say 1000 GB of hard disk capacity, and let's take some example of um, three CPUs, let's say something like that, right? So this is our requirement today, but as our company grows in revenue, in the user base, it has become big today. What happens is, because we have hosted everything in the single data center, what we need to do is we will have to increase the infrastructure for this. Tomorrow the requirement might become, we need 200 GB of RAM, we need so many databases. Like today, if we are looking at 10 databases, tomorrow we may need 100 databases, right? So it results in increase of hardware infrastructure, right? So what we will have to do is we will have to start buying the hardware components, right? So that is associated with cost. Now, user base, when the user base grows, we cannot uh, predict it, right? So suddenly we may have a significant change in the requirement of hardware. So what people does is, what companies does is, they will already buy some extra amount of hardware, assuming that this will grow in future. So if the requirement is 100 GB today for RAM, what they'll do is they'll buy 200 GB of RAM as a precautionary measure. So in case if requirement increases, we'll still have a capacity of 100 GB as a buffer, right? Now this is going to increase cost, because what if the requirement is floating? What if today it is a requirement of 200 GB, tomorrow it is a requirement of maybe 50 GB or 60 GB, right? It depends. It depends on the user base. So because this is floating requirement, companies are actually buying it as a fixed requirement. The cost is going to increase. They are going to buy infrastructure that they don't need today, right? So there is a cost associated with this problem of buying more hardware than you require. The third problem of this data center is data availability, guys. So let's say we are talking about a US company and we are sitting in India trying to access that US based company. What happens is that because the server is located far from our location, there is a high chance that data might be available at a later point of time, which we call it as a latency. Latency means the time duration of data arrival between the request and the response. So let's say you have requested for some information. What happens is that the request is gonna hit your server, and server is going to process your request and send back the data to you. Now the duration between this request and response is known as a latency. If your server is stored far from your place, there is a high chance that the data availability or the response time, which we call it as latency, is going to increase. And generally companies who run business doesn't like latencies, high latencies. because they feel like, it shouldn't buffer. Let's say we are watching Netflix movie, we don't want it to be buffered, right? We want it to go smooth. So this is another problem of hosting everything in a data center, right? So there are some more challenges that we are going to cover at a later point of time. But for now, please understand that these are some of the challenges of hosting everything in a single location. And let us also assume that we are talking about a small MNC, for example, which is why we are talking about only as hosting a single data center. There is a possibility that there could be multiple data centers as well, which we will talk about in the upcoming sessions. Okay. So within this small company, what happens is that, let's say we are talking about a e-commerce company. All right. So within an e-commerce company, there is a possibility that they have data for products, they have data for orders, they have data for sales, right? They have data for user management, which we could call it as a customers, right? So they have data for multiple things, right? So what they are going to do is they are going to host different databases for different purposes, right? So here what happens is that when the e-commerce company is small, let's say this is not a big MNC, what they're going to do is they are going to have a discussion. The managers, the stakeholders, the project leads of this company are going to have discussion on a periodic basis, on a quarterly basis, or on a monthly basis about how their company is doing. So what happens is all of the stakeholders, managers are going to have a periodic meeting about how their product is going in the market and how they can improve. And they will also try to compare their profits from the previous month or previous quarter, something like that, right? So what they are going to have is they are going to have questions about their e-commerce platform, right? To answer these questions, right? So to answer the questions about their current performance, their current product performance, what they will do is they are going to hire a person called data analyst. Okay, so what they are going to do is, because they are not so technical, because they don't understand accessing these many databases and then collecting the information, what they will do is they are going to hire a person called data analyst. Okay, so if you look at some of the questions, maybe they'll ask, let's say, why are our profits down? Um, or maybe they'll ask how to improve sales for a particular region or a product. Let's say in the products, they have one of their products is going down since long. So maybe they'll have certain questions that are based on the data that they have, right? So what they are going to do is they are going to hire a person called data analyst, and they will say, boss, these are our questions. Now you tell us what is happening with our product and with our data. So the data analyst, let me show you that. Yeah. So the data analyst, now this person is going to access all of those internal databases. It need not be databases always. It could be from Excel sheets. It could be from API. It depends on the company. It depends on the business they are running, right? So they are going to run the SQL queries. If it is database, they are going to extract data from APIs. They are going to extract data from spreadsheets, and they are going to prepare a solution for all of these questions. So what they are going to do is they are going to clean that data first. They are going to run the queries to gather the information, and then they are going to clean that data. And then what they are going to do is they are going to prepare a visual report on top of this information. So once they have cleaned that data, they are going to prepare a report. Report as in it's a visual, like I know a pie chart or a bar chart or a histogram chart explaining why is our profit going down? Why is this product, not giving us much revenue? How is our sales looking like in the past 6 months? Kind of, what is the cumulative average? of each and every product. Like that, they are going to answer all the business questions through a visual report, right? Generally, the visual things happen using Power BI or Tableau. There are multiple ways to do it, but the data analyst is going to answer business questions using the data. Okay. Now, what this data analyst is going to do is they are going to communicate, they are going to do a storytelling to the managers that, okay, boss, this is the reason why it is happening. Okay. So this is the role of data analyst, guys. This is how the analyst is gonna work. Any questions on the role of data analyst? I mean, this is just a high level of how a data analyst works and how companies look at data analyst.
It's clear.
Okay. Let's move ahead of what are the challenges what are the challenges with the data analyst role and why we need a data engineer, right? So if we go back to our example, we are talking about a small company with small little database, like less databases with some questions on the overall performance of the organization, right? Now assume that this e-commerce platform has grown into something called Amazon. This has become huge. Okay, this has become a huge success. Multiple people started using it, so this has become Amazon today. Now assume that they are going to have so many sources, right? They are going to store product reviews, they are going to store the product images, product videos, customer feedbacks, right? They are going to use everything. Even if you click on a product, that will also generate a data, correct? So the data itself is going to be huge. So to answer these business questions, it will be tough for a data analyst. If you see this, if it will be tough for a data analyst to query, to extract data from multiple sources on a regular basis. He cannot do it on a regular basis from so many systems. And also there are challenges when you query so much of data. There will be cost associated with it. You cannot write a query on a big table which is storing billions of rows, right? It is going to uh, increase the cost. It is going to delay. It may even crash sometimes depending on how much amount of information you are extracting, right? So these are certain challenges to gather the data and clean the data for a data analyst when the volume is huge, when the companies are big like Amazon, right? So what happens is now the data analyst is not able to do this operation, the extraction part, the cleaning part by himself. So what these organizations do is they are going to hire somebody called data architect, right? Let me write it. So what they are going to do is they are going to hire somebody called data architect. Now what this data architect is going to do is he is going to design a solution to extract, transform, and prepare the model. I'll talk about what a model is, but for now, just go with the flow. So what the data architect is going to do is he is going to design a solution to extract the data and transform it and prepare the model on a periodic basis. If the requirement is to have this answers every day, he is going to design a solution that will give you the answers to these questions on a everyday basis. So the frequency is decided by the management, and the data architect is going to design a solution accordingly, right? So if we look at the other screenshot here, this is explaining the same. So the data architect is going to provide a solution. He is going to build a data system that says, okay, boss, these are the some of the sources that you have, and this is how we are going to prepare a solution for your data analyst. So the end user for a data architect is data analyst. Okay, he is doing this for data analyst. So what they are going to do is they are going to gather the information through multiple sources, which they call it as a pipeline. We'll talk about what a pipeline is in detail in the upcoming sessions, but for now, please understand that this is just a way of gathering all the information, a predefined set of code. Okay, we'll write some uh, programming logic to gather information from multiple sources. Let's say, for example, it's a Python code. Okay, we'll use Python code and we'll start connecting multiple things using Python. We can call it as a pipeline for now. So what they are going to do is they are going to design this data system. Okay, they are not going to use this, they are going to design this and they are going to present it to somebody called data engineer. Okay, now what they will do is the data architect is going to explain this solution to data engineer, and data engineer is somebody who is going to work on that solution. Okay, guys, please feel free to ask me. This is just to clarify the roles. So once the data architect is going to design a solution that, okay, this is how you have to extract, this is how you have to transform, this is how you have to prepare a model. Data engineer is going to take those requirements and he is going to work on that solution for data analyst. So the end user of data engineer is of both. I mean, for both of them, the end user is data analyst, right? It could be so many people, but for now, for in this example, just go with the flow that the end user here is data analyst. So the data engineer is going to look at the pipeline, and what they are going to do is they are going to start doing this activity as defined by the data architect. If data architect says do this on every day, he is going to build a pipeline that runs every day. Okay, if data architect is going to tell you run this pipeline every hour, he's going to run this every hour. So what they are going to do is they are going to prepare this pipeline. They are going to create multiple layers, guys. This is the standard format that industries use: bronze, silver, gold. This is known as a medallion architecture, which we will discuss when we talk about Databricks. Okay, we'll implement this also. We'll do this as a practice. But for now, please understand that these are three different layers. First layer is bronze. So here, whatever raw data is extracted through pipeline, it will be placed here. Okay. So what they are going to do is when the solution is decided, data engineer is going to work on this pipeline and he is going to create this. So in the bronze layer, what data engineer is going to do is he is going to upload. In simple terms, I'm saying he is going to upload multiple sources of data. Okay. So if he's extracting data from APIs, if he's extracting data from databases, he's going to dump everything as is. It's a raw data, unfiltered, untouched. Okay. Then what he's going to do is he's going to use this data and he's going to clean that data as per the transformation suggested by data architect. So who is going to give you the list of transformations? Data architect is going to give you the list of transformations. How is data architect going to know what transformations should be applied? Because data architect is going to connect with the management on these questions. Okay, so they are going to discuss mutually as to what business is expecting, and then he is going to decide the transformation questions, right? Then clean that data based on the transformations provided by data architect, and then he is going to store that clean data for aggregations. Right now you have cleaned the data. Well, I'll take one example here. So let's say we have a column called date of purchase. Let's say somebody purchased a product on, let's say, 1st uh, January 2025. Okay. So to clean the data, what they are going to do is, let's say the expectation is that whichever format your date of purchase is having, make sure that you are standardizing it to something like 1/1/2025. Okay. This could be 1st Jan, this could be, 2nd, um, like this. It could be in any format. Okay, you have to make sure that you are transforming all the date columns into a standard format, because in the visuals, I think you all know that we need to clean the data in a proper format so that visuals are not broke. So this could be another reason. Sometimes you will see null values where the customer name, let's say customer ID is present, but somehow customer name is like devil or Spider-Man. right? So what they'll do is they cannot have this Spider-Man in the visual, right? So they are going to do some cleaning. They are going to talk to data architect about, okay, we see some invalid names, we see some invalid IDs, we see invalid dates, right? So based on those requirements, they are going to discuss and they are going to clean that data. Sometimes you see null values, duplicates, missing values, invalid formats. So many things are going to happen. We'll discuss all of that. So assume that they are going to store
So,
that clean
while
data.
cleaning this data, do they take a copy of production database or do they perform on the production database?
Good question. So generally what happens is I did not touch this here because it's too complicated. So they are going to have multiple environments. What they will do is they are going to have at least three environments, which they call it as
Mhm.
UAT, staging, and production. And the namings are different in each organization. Somebody like in my organization, they don't have staging. They call it as UAT, FIT, and prod. Okay, in some other organizations, they may have like test,
Dev UAT.
dev, and prod, right? So these namings are different, but there will be a minimum of three environments. Okay, so one
Mhm.
is for developers, one is for somebody who is testing the development activities, and somebody who is working on the development features. The third environment is for actual production. So they are not going to touch the production until unless they are satisfied with the outputs of development and test environments. Okay, for our easy understanding, let's go with development, test, and prod. So all of this is going to happen in development first. Okay.
Okay.
Yeah. So development, test, and prod. Let's not have test. Let's have staging. So all of this is going to happen on the development environment, and data engineer is going to work on this. So data engineer is not going to, work on this alone. There will be multiple data engineers that are going to assign the transformations. There are, let's say there are 10 transformations. The two data engineers are going to work on five or six data transformations, because sometimes transformations are so complex, guys. It's not as easy as cleaning nulls. We'll talk about those complex transformations in the upcoming sessions, but for now, please assume that they are so complex, and there are multiple data engineers working on the same solution. That is a high possible chance. So they'll work on development environment. They'll clean the data in the silver layer. Once the data is cleaned, this is cleaned, what they'll do is they are going to aggregate the data in the gold layer. Okay, they are going to use that data and they are going to aggregate the data again based on the business requirement. So business is going to give you everything. Okay, you need not design a solution. There are roles in the industry that are going to give you everything that you need to work on, and you are going to follow those instructions, guys. Okay, so data engineering is, maybe somebody might have told you that we are going to do everything. That is the future, but for in the current industry, it is not happening. There are multiple roles like data architect, product owner. There is a scrum team actually who is going to work with you to design this solution and to prepare this business scenarios. So you are going to aggregate the data. So this aggregation of data is nothing but a model. So this is not a machine learning model. This is a data model. We call it as a data model. If you have heard about data modeling, this is the data model that we are going to prepare. And once the data model is prepared, we are going to prepare something called cube. Okay, cube means the the layer which stores the aggregated data. Okay, so let's say we have two tables. One is sales aggregation, like this is going to have everything about sales in aggregated manner. One is about products or customer reviews aggregation. Okay, so this is going to have aggregated data for all of the products and customer reviews. So this can be considered as a cube. This can be considered as a cube. Model is going to define how you want to aggregate the data. Cube is going to store that aggregated data. Okay. We are going a bit deep, but I just want to give you a complete overview of how a data engineer works, how a data architect works, and how a data analyst works. Now, because data engineer is going to aggregate the data and he is going to give you this aggregated output. If you see this diagram, the data engineer is going to do this for the data analyst. If you see the gold layer, here the model is being prepared. Now, the data analyst is going to use this aggregated models or aggregated cubes from the gold layer, and then he is going to directly run a SQL query as and when required by the company, by the stakeholders, and then he is going to give you a solution or on a visual report to the organization. Okay. So in case if we have to do this activity multiple times, the data engineer is going to schedule this pipeline based on the required frequency by data analyst. If analyst says, I need this data every day because management is asking a review of this data every day, then the SQL, the data analyst is going to ask the data engineer that, okay, please refresh this every day, and data engineer is going to schedule this pipeline. So nothing is going to change. Okay, it is going to get triggered every single day for the analyst to do this activity. However, in some organizations, what they, I mean, if it is a so big organization, they will also have somebody called BI developer who is going to own the activity of refreshing the dashboards. Okay, so what they are going to do is the data analyst in that organization is going to give you a one-time solution for all of your business questions. Okay, he is going to work on the historical data that happened till today. But for the data that is going to come today and tomorrow and day after tomorrow, this data analyst is not going to do anything. Data analyst is going to depend on BI developer. Okay, he is going to prepare the dashboard, and BI developer is going to refresh that dashboard. He is going to create a connection between the gold layer and the dashboard, and he is going to ensure that the dashboard is getting refreshed every day on every periodic basis as defined by the business. So they are going to have two separate roles in many organizations. This is how it goes. They have BI developer, they have data analyst. Data analyst is going to do a limited job of just answering the questions at once, but BI developer is going to maintain that um, visual things, okay, on a periodic basis. Any questions?
So BI developer, he knows from where he need to get
Yes.
like information. So he knows what, like he developed all the queries and everything, right? So he can get everything from the databases. So what exactly that data engineer will do in between?
Yeah, so if you remember, we have discussed that if the data is at a large scale, right?
Okay. Mm-hmm.
So when the data is at large scale, when the data is not structured, okay, when the
Okay.
data is not in a usable format, it becomes tough for a BI developer because they are more technical in terms of explaining the data. They are not more technical in terms of gathering and cleaning the data, right?
Okay.
Also,
Okay.
the challenge is that you have to prepare a solution that runs by itself.
So as a data engineer, he scraping whatever you said. He do all the stuff and he prepare one database for the data analyst. Is that right?
Yes, he is going to
Okay.
prepare a data warehousing solution for a data analyst or for a BI developer to look at.
So once we develop that one data warehouse, then data analyst will point all his applications, whatever it is, to the data warehouse.
He is going to query that data warehouse.
Query the data warehouse. Okay,
Yeah,
got you. Thank
directly he
you.
is going to query and he is going to give the solutions. Okay, good
Got
question.
you.
Okay, okay, guys. Good thing that that's how the roles work in general. That's the difference. You might ask me, okay, there is data scientist, there is machine learning engineer, there is AI engineer. What are they going to do in this particular example? Um, what happens is that there are different types of analysis, guys. Some you we call it as descriptive analysis, diagnostic analysis. I am not sure if you have heard about these terms. There is predictive analysis, right? These are some of the types of analysis on data that we do. Descriptive analysis is nothing but anything that happened in past. This is generally answered by somebody called data analyst because he's already having the data with him. So he's going to answer what happened. Okay. It is nothing but what happened in the past. Diagnostic thing is again related to past. Again, data analyst is going to answer about what, how it happened. Okay. This is like diagnosis of how it happened. Predictive is going to be future, guys, and data scientists, ML engineers. I mean, the terminologies could be different, but you know, the engineers who are going to use AI, I'm giving a general term. All of those are going to work on this future. They are going to say how it is going to work in future, or anything about future, guys. They are going to answer questions about future by looking at the past data. They are going to do a prediction. They are going to build predictive models, machine learning models that look at this trained data. They are going to train the data on the past, and then they are going to predict some scenarios in future. So let's say how is our profit going to look like in next 6 months. So they are going to look at the past data for the past 6 months or past 1 year, and they are going to predict that, okay, for this product this is how your profit is going to be, for product B this is how your profit is going to be. So they are going to work on the predictive analysis of the data. Data analyst is going to work on descriptive analysis of the data. That's how the roles are defined. This is more or less this is going to be same across industry, irrespective of whether we are looking at e-commerce or any other organization. More or less this is going to be the roles. Okay, cool. So now that we have understood different roles, we can continue talking about the big data, guys. Let me actually, um, yeah. So we will talk about the data flow in general that happens in our computer. I mean, most of you are already aware. This is just a refresher. So we have a processor in our computer, which we call it as, I mean, which contains CPU and other stuff. Then there is a RAM, random access memory, that is going to have a limited memory, but it is going to be fast in accessing anything. We are going to have hard disk. Hard disk is going to be a permanent storage, which is carrying more capacity, but it is little bit slow. Okay, it is going to be non-volatile, which means data is not lost even if you turn off the computer. RAM means volatile, it is going to lose the data as soon as you shut down the computer, right? This is the basic theory that we know. Now, imagine this. Let's say we want to access a CSV file that is present in our hard drive. Okay, let's say we have abc.csv present in our hard drive. What happens in the system is the CSV file is going to sit in hard drive. When we double click, when we try to open it, the CSV file is going to be brought back to RAM. Within the RAM, the CSV file is going to open. Okay, and then we may apply some logics on that CSV file. We may add or modify the data. Whatever we do, that CSV file is going to come and sit in RAM. Okay, so this is how generally the thing happen. Assume that this CSV, the RAM that we are talking about is of 4 GB. Okay, the hard disk is 500 GB. Now assume that we have a file of 10 GB that we want to access from our hard drive. Hard drive, because it is 500 GB, it can store 10 GB, right? So it will store 10 GB, but we want to open a 10 GB CSV file, guys. So what happens is, because you want to open a file that which carries a size less than, no, greater than your RAM size, the system is going to crash. You agree? Because the size of the file is greater than the size of the RAM, right? So what happens here is that your system is going to crash, and i- because we because I mean, the size of the file is greater, what we will do is we are going to use something called a distributed way of accessing the data. So what we will do is, instead of accessing the 10 GB file in a single machine, we are going to distribute this 10 GB file into multiple machines. And what we are going to do is, let me write it down here. So let's say your hard disk, your RAM, file size, um, it's 500 GB, it's 4 GB. This is a standard configuration that I'm expecting. If the file size is 1 GB, it's fine, right? There is no problem. But what if the file size is 10 GB with same configuration? Then system is going to crash. So to avoid this, to read the data that is greater than your RAM, what we are going to do is, instead of using single machine, what we'll do is we are going to distribute this 10 GB as 2 GB per machine. Okay. Or rather, let's make it 2.5. Okay. So we will create machine 1, machine 2, machine 3, and machine 4 with same 4 GB RAM. Okay. So the RAM is going to be 4 GB for all these 4 machines. Now what we are going to do is we are going to divide this 10 GB into 2.5 GB, and we are going to read this in a distributed manner. So our system is not crashed at any point of time and we are still accessing this data. Okay. This concept is first proposed by Google, guys. Okay. So Google proposed this concept and they call it as GFS. Okay. GFS means it's Google File System. This was launched in long back ago. So Google first said, instead of accessing a 10 GB file in a 4 GB RAM in a single machine, let's do it in a distributed manner, right? So this was first launched by Google, and then Yahoo company came up with something called MapReduce. Okay, this is so what they have said is, okay, you are accessing it in a distributed manner, that's fine, but how are we going to merge it? When we need 10 GB file as the output, right? We cannot work on pieces of data multiple times. So they have come up with something called map reduce. Now map reduce is nothing but, this is two terms, right? Map and reduce. So map is nothing but whatever transformation, whatever cleaning or whatever transformation that you want to apply, you are going to apply, let's say we have transformation 1, you are going to apply this transformation 1 on all of these 2.5 GB files individually. Okay. So you have a transformation, you are going to apply individually on each of this partition. I'm calling it as partition. In the reduce phase, you are going to bring back this 2.5 GB into 10 GB file. Okay. Now, this is how the map reduce was defined. I know, I mean, you may have some questions. Let's just hold on. So this is the theory of map reduce, guys. So Yahoo proposed this, and what they have done is they haven't worked on this map reduce concept. They just provided a theory. So after some years, Apache came up with something called Hadoop. And what they have done is they have integrated the map reduce concept within Hadoop. Okay. So what they have done is they have said that, okay, we are going to have three systems. One is storage. Let me write it here. One is storage. One is compute engine. This is important. Please pay attention. And the other one is resource manager. Okay. So what they have done is they have come up with these three components in the Hadoop. So what they have said is, Apache said is, we are going to use a distributed storage, right? This 2.5 GB files, if you see, we are going to use the distributed storage here, call it as HDFS, Hadoop Distributed File System. So whenever you store a file in HDFS, automatically it is going to divide those files into number of partitions. Okay, we call it as partition here. Each 2.5 GB file is called as a partition. So if you apply if you try to load a 10 GB file in HDFS, automatically it is going to divide those 10 GB files into multiple parts. Okay, how it is going to divide, on what basis, we are going to discuss. Okay, later point of time. Compute engine is nothing but map reduce. So how are you going to process this 10 GB or 2.5 GB files? Okay, that is done using map reduce. So map reduce is going to define what transformations are going to be applied on this divided files, partitioned files. The resource manager, they have said, okay, we have something called yarn. Yarn is nothing but yet another resource node. What it does is, this is going to assign or allocate computer machines to the HDFS, to the map reduce. So let's say here in this case, we are talking about four files, four 2.5 GB files, right? So each of them are going to consume 4 GB of RAM, which means this is a single machine, guys, right? This is computer 1, this is computer 2, this is computer 3, and this is computer 4. So because we require four computers, Yarn is going to provide the four computer resources to the MapReduce to process this 2.5 GB of data. So in a summary, if you have a 10 GB file, HDFS is going to divide the 10 GB file into, okay, into four parts. MapReduce is going to apply your transformations. Yarn is going to give you the computer 1, computer 2, computer 3, and computer 4 to do this activity. Okay. So Yarn is going to have a group of computers within inside. When you configure Hadoop, you are going to do this. You are going to decide how many computers you want to have. And each of this computer is going to be assigned for each of this partition. Okay. Now, each of this computer is called a node. This is nothing but a node, guys. In the industry, we call it as a node, and the group of computers is known as a cluster. Okay, so group of nodes is nothing but a cluster, guys. So Yarn is going to provide the clusters with group of nodes for processing this 2.5 GB of data, and then MapReduce is going to do the transformations. Okay, so when we are going to work on these transformations, there is a possibility that some of these computers may go down, they might be shut down, they might go off, right? They might fail sometimes. So Yarn is going to manage with some other extra computers. What they'll do is, if computer 2 gets failed, they are going to immediately assign computer 5 to it. Okay. And one more point to remember, all of these computers that we are talking here are not physical computers, guys. They are virtual computers. Okay. They are virtual machines. Okay. So this is handled at the back end. We don't have access to decide whether we want to use computer 5 or computer 1. Yarn is going to take care of everything in terms of resource management. We can tell Yarn about how we want Yarn to configure this. Okay, let's say if you want computer 1 to have a 2 GB memory, 2 GB RAM, you can tell Yarn that, okay, I need 2 GB RAM for all of these computers. So it is going to provide 2 GB RAM. Okay, so you can define the configurations, but you cannot decide which computer should work on which partition, on which map reduce concept. Okay, please remember this. This is going to be super important when we talk about Spark and when we talk about the distributed computing. Okay, so let's gather for any questions, guys. Any questions on this
Yeah, I just
concept?
Yeah.
have a quick
When you
question.
do this
Uh,
compute elastic this one spreading to multiple four servers or five nodes or something, you are
Mhm.
paying extra cost, right? Why instead of that one, why can't you add extra memory to read that file?
Yeah, good question. So the challenge is that the advantage of doing this and the disadvantage of adding more memory is that let's say today the requirement is that you have a 4 GB RAM and you have a 10 GB file. Now you are
Mhm.
saying that let's make it 15 GB or 16 GB today so we can work on 10 GB,
Okay.
right? That I think that's your point. So
Yeah.
the disadvantage of doing this is we are working on a single machine. So the problem is if this machine is gone,
Mm-hmm.
I'll not be able to process this 10 GB at all. That's a disadvantage. Okay. The second disadvantage is the requirement here is just the 10 GB and 16 GB. But assume that we are working on TBs or
Okay.
GBs. This is just
Mm-hmm.
a simple example. Assume that we are working on TBs. We may not be able to assign TBs of RAM, correct?
Yeah.
That is going to throw some random cost that we cannot imagine because the data is huge, guys. We have to think in terms of handling large volumes of data. This is just a
Mm-hmm.
sample to discuss, but understand that there is multiple sources of data with huge volumes. So we cannot trust a single source of uh, computer to do this activity. And the
Got you.
third reason is this is floating. This is not always 10 GB. Today it could be 10 GB, tomorrow it could be 1 GB.
Mm-hmm.
So what happens is tomorrow if the data is less, if users are using less data, tomorrow if it becomes 1 GB, then 16 GB would be unnecessary cost, right? Here what happens is this yarn is going to adjust the memory. We can decide, okay, because we are partitioning the data, right? So what we will do is we will change the partitioning logic when it is 1 GB. We are going to say because it is 1 GB, now you partition only 250 MB.
Okay.
So we will tell the yarn that okay, we will tell HDFS that okay, my file is 1 GB today. So you instead of making it 2.5 GB, make it 2.5 MB and 250 MB. And this we will define the yarn cluster configuration as I need only 1 GB per computer.
Yeah, that makes sense.
So I will configure based on the data here in the yarn and HDFS. So that way I am reducing the cost. I hope I was able to answer.
Yeah. Yeah.
Okay, so that this is one of the reasons why industry is looking at using a distributed way of processing the data because they can reduce cost based on the volume of data that they see on a daily basis or on a periodic basis. Good question. Any other question, guys? Okay. Um, I'll take it as a no. If there are no questions, please feel free to add questions in the chat as well. It's okay. Let's move on to our last topic for today, which is talking about the big data and the 5 V's of big data. So we have spoken about the data volumes just now. We have assumed that the company is growing and the data is growing on a daily basis. So that is nothing but big data, guys. And data engineer is brought into picture only because of this big data. If it was not big data, then there was no data engineer. Data analyst and other roles would have done this activity already. So because this is big data and the data cannot be handled, they have brought in the pipelines, they have brought in all of these tools that you are seeing today, Azure and Databricks and all of that. And big data is the main reason of all of this. Okay. So big data is having a principle of 5 V's. Okay. 5 V's as in whenever we are working on big data, we have to discuss and decide about these 5 V's. Okay. What are these 5 V's? First V is about volume. Okay. So before you process or work on any data, you need to understand how much of volume you are looking at. Okay. That is the basic principle of big data. You have to understand the volume of your data and then you have to decide the solution. Second is velocity. Velocity means the speed at which the data is generated. Is it going to be generated on a daily basis? Is it going to be updated on a hourly basis or a monthly basis? Accordingly, you have to work. Okay. Then there is variety. Variety is types of data. Types of data as in structured, unstructured, semi-structured. Accordingly, you have to decide. We are going to talk in detail about structured, unstructured in our next sessions. For now, just understand that varieties of data. It could be in CSV, it could be in Excel, it could be in JSON. Accordingly, you have to decide the processing methodology of big data. Then there is veracity, guys. Veracity and value are newly added. Earlier, it used to be three V's. Veracity means trustworthiness of data. So, how much we can trust the data that we are looking at. Okay, so we will take an example. I'll give you some analogy on this, but for now you understand that trustworthiness, how much we can trust this data that we are generating or that we are processing. Value is whatever we are doing for this data, is it giving us any value? Is it helping us or not? Why are we doing this? Okay, so if there is no value of processing big data, then there is no need of processing that data, right? So the if it is adding a value, then only we'll have to process the big data. So these are some of the five principles that we have to follow or we have to discuss whenever we are talking about big data, guys. Let's quickly take an analogy on the big data. Again, I'm going with my favorite organization, Amazon. I generally use this a lot. So we talked about five V's, correct? One is volume. I'm sorry, it's volume. Then we talked about velocity. Then we talked about variety. Then we talked about veracity. Then we talked about value. Okay, right. So when we say volume, guys, let's assume that we are talking about 5 V's for Amazon. Okay, so what could be the volume, right? So in today's market, if you see, Amazon is going to have, I mean, so many products in their database, right? So they have millions of products, right? So that could be a volume, right? And the other item could be, so whenever you click on an item, so that click is going to trigger it is going to record that you have clicked on a particular item, guys. That's how you are going to get recommendations. That's how you are going to get last recently viewed. If you see, there is a tab called most recently viewed. All of that is generated because you have clicked on a particular item, right? So we call it as click events. Okay, those could be millions, right? Again, there are so many users, though there are so many clicks happening on a daily basis. So let's assume that there are millions of products and millions of click events happening, and that could define our volume, which means that it's a huge amount of data that is getting generated, right? If we talk about velocity, so the speed at which data is generated, guys. Okay, so what could be the example for Amazon? Um, if you
You can
think
you
about,
can take like when you have a Thanksgiving Day or Black Friday deals during the time you'll get a huge data you'll get in a day.
yeah, yeah. So what happens is that let's say you have picked a product of, let's say you are buying an iPhone. What you do is you are going to add that iPhone to a cart, correct? Whenever you want to buy a phone or any product in Amazon, what you are going to do is you are going to add that item to a cart. Now, if you see, as soon as you add a item to a cart, immediately the cart is updated. You agree? Immediately, in seconds, it gets updated. Okay. In reality, in the backend, iPhone is sitting in something called a product table. Cart is something else. It's a different table, right? It's a different database altogether. Even though they both are different databases, when you add a product from one of the database and to a cart, the speed at which the iPhone is getting added to a cart is real time. It will be added immediately, right? And when you hit on place order, the order is immediately placed, correct? So all of this is happening at a speed of light, which talks about the velocity, because the cart is getting updated immediately, the order is placed immediately. Immediately means the speed at which the order is happening, the transaction is happening, right? That is a good example for velocity. Okay. Variety means different types of data. So if you look at any product in Amazon, you will see product information, correct? You will see customer reviews, correct? You will see customer product images, product videos, okay? So there is variety of information hosted, guys. Customer reviews, can we consider it as text? Images and videos, it's already unstructured for us. Product information could be something that's sitting in database. So we can consider it as tables. So this is variety of data, right? Customer reviews is the text, could be in text format, then product information could be in tables, images and videos could be unstructured data. So this can be a great example for variety. Veracity means accuracy and trustworthiness, guys. So generally we sometimes we have a belief that when we see customer reviews, guys, there is a high chance that some of the reviews might be fake. They are not genuine. They are not trustworthy, right? Some of the videos that we see, what they'll do is let's talk about iPhone. Sometimes what they'll do is they'll immediately post a review saying that this iPhone looks good immediately after getting the delivery, right? They'll open the product and they'll immediately rate it 5 star, right? So there are certain fake reviews and fake videos that are not trustworthy, right? So this could be another example of veracity. Also, if you think about this, people who are selling these products through Amazon, okay, they are known as sellers. So the validation of this seller, who is selling this product, okay, if there are any fake sellers, or if there are people who are selling fake products, that could be an example of veracity. So this will also generate data, right? So we have to validate and identify any fake reviews, we'll have to identify any fake sellers. All of this comes under veracity, right? Now adding a value is like you mentioned the example, right, on a great Indian festivals, on any flagship days. We can talk about that here. This is like um, providing you some discounts on a personalized discounts, I would say. Um, okay, so let's say you are a loyal customer to Amazon. Maybe you get more discount, or um, like you may get fast deliveries. So all of these are some special advantages of you know being a loyal customer to Amazon. Now, how is Amazon going to understand that you are the loyal customer, you deserve a extra discount or extra offer? Based on the data that they have analyzed for you. Okay, so if they are not giving you a personalized discount or some benefit on any product, their business is, I mean, the data they are generating for users is gonna go waste. Okay, user data is specific to understand what products you are ordering on a periodic basis, what type of products, what categories of products, and how can they make you order more, right? So they want you to order more. So what they'll do is they'll give you personalized offers. If you are ordering phones, if you are ordering some of the electronics, they are going to give you personalized offers sometimes. So this is how they are going to generate value of out of the data. I believe we have done with our class today. So these are the 5 V's of big data, and this is how we are going to um, relate it. I mean, any questions on the entire class that we had today? Any questions or any topic that you want me to revisit? Yeah,
No.
One quick question. I want to know the difference between data analyst and BI engineer. I thought they kind of work similar things.
yes. So in certain organizations, the data analyst role is going to be more of a data analyst plus BI developer. In certain industries, because there are so many teams, so much of data that they have to work, what they'll do is they'll create a BI team that is more focused on creating visualizations. They'll not look at data at all. They'll just fetch the data. They'll build the reports. So they will divide the data analyst task into two parts. One is uh, answering the questions on the data that is given by the data engineer. The other part is refreshing and updating the dashboard that is created. So dashboard is built by the SQL, I mean the data analyst first, but it is maintained by the BI developer throughout the cycle. So data analyst is going to only work on a project once. He is not going to maintain it for years. So let's say a project is going to continue for 2 years or 3 years. Data analyst is going to do it only once. He is going to prepare the dashboard only once. For a periodic review, for a periodic updates, for a periodic refreshes, everything BI developer is going to work with the data engineers. So it's similar. It's always same. It's just that due to the situation of the organization, or the organization generally plan to have two different teams, one who is more focused on preparing the dashboards and visualization, one who is more focused on storytelling or communicating. So the data analyst is going to take a lead in communicating or answering the business questions, whereas in the backend, the BI developer is going to generate the content.
Okay, thank you.
Yeah. Any other questions? Okay. If that is a no, then thank you so much. I'm stopping the recording.